for the drums.
Hey guys.
Hey, Keith.
Hey, Keith.
Hey, so I want to continue with our mental models. We've covered a lot of granularity and aggregation. And now what I'd like to do is move into these other concepts, the difference between discrete and continuous. And today's episode will be more of a theoretical conversation, and then we'll come back next week and follow up with a little bit more of the practice, the applied applications of discrete and continuous. But
All
for
right.
now, a little bit on the theory. I'd like to start with an open-ended question. Ketchup. Is ketchup discrete or continuous?
Hmm.
Do you mean in how ketchup pours or how?
Right. I don't
Mm-hmm.
know. I mean, and then
Mm-hmm.
its arch rival mustard.
Yeah.
Ketchup is evidently discrete and distinct from mustard, right?
Mm-hmm.
But then within ketchup, is there not a continuum of ketchup? I mean, you have spicy ketchup and you can have ketchup that's a little bit more barbecue. But if we're going down to Robert's neck of the woods in Texas and we get into the barbecue neighborhood of ketchups, is there not a continuum of ketchups? I mean, is it really
Mm-hmm.
possible to identify when barbecue ketchup becomes spicy ketchup?
Yeah. I mean, we could delineate it based on brand, based on quantity, based on all sorts of um, discrete units. What size and shape bottle is it in? What label does it have on it? But if I'm just pouring out some ketchup, well, that's a continuous pour,
How much
right?
ketchup did you pour? That's a continuous pour.
Mm-hmm.
But then on the
Yeah.
other hand, if we were to say compare ketchup and mustard to say elephants and tigers, is it not just that ketchup and mustard are both sauces and elephants and tigers are discrete animals and we
Hmm.
might choose to bin and bucket ketchup and mustard together in that circumstance?
Yeah.
So I think you get my
Mm-hmm.
point, right? Is that these concepts of discrete and continuous, they can be a little bit fuzzy. So I want to go through today this philosophical
Mm-hmm.
proposition that I have, that really, as sense makers interpreting reality with data, there's really only just one continuous. And so we're going to talk about
Mm-hmm.
this difference between discrete and continuous. And it's really a question of finite versus infinite possible values. Okay, so we've covered in the past dimensions and measures, so we're not going to re-go down this rabbit hole. There's other material that we've covered in the past. Dimensions in Tableau determine the level of detail, and measures, they aggregate to that level of detail. And thanks to our good friend and community champion, Joe Mako, from so many years in the past, these days when I look at data, I just put my goggles on and all I see are dimensions and measures. But that then is only half of the equation when we begin to consider now these other facets of the variables and measures that we have in our data, discrete and continuous. So continuous variables, they measure these fluctuating values like that continuous pour of ketchup that Robert mentioned. And that continuous pour can occur over some non-empty range of all possible real values, right? There's a continuum of the amount of ketchup that can pour out of the ketchup bottle. Whereas discrete values, on the other hand, those can be only certain distinct discrete values. And those can occur within a given interval. And that interval could be either the sauce is ketchup or the sauce is mustard.
Mhm.
Or that discrete interval could be these are sauces, these are animals, right? And
Mhm.
so these continuous variables, those actually could come out of the measurement machine as any number of an uncountable set of infinite possible values. There's a continuum. It's infinity in terms of the number of possible values that can come out of that measurement. Whereas the discrete measurements, those can be only a distinct set of a limited set of values that are possible to measure. And so this is one of your slides, Jonathan, where you presented to me, this is a continuous scale. So this scale with the radial dial there, when I put my apples onto the scale, is gonna give me measurements in a continuum, because the dial is this continuous dial, and there's really no finite boundary between one measurement and the next. In theory, every new little grain of sand that I put onto the dial it can increment the measurements that I receive off of this scale infinitely upward, with an infinite possible number of values that are coming out of the measurement, coming out of the reading. Whereas this scale, on the other hand, this digital scale, is going to give me discrete measurements. It's going to have some type of um, kind of specificity to it, where, like, so for example, in this kitchen scale that I have, this digital scale, I can measure in ounces or in grams or in pounds. And in either case, it's going to give me, say, 2 decimals or 3 decimal points of precision. But then after that, any extra amount of precision that's in the 4th or 5th or 6th decimal place is just going to get lumped together into a discrete bin that is the amount of precision that this discrete measurement device is able to handle.
So, Keith, to use your ketchup analogy, what I'm seeing here is there's a difference between measuring how much ketchup we pour out of a given container versus discrete groupings of, here's a 12-ounce container, here's a gallon container, here's a sample packet container, right? It's these groupings of measurements. Is that kind of what you're getting at here?
Yeah, that's kind of what I'm getting at. Let's get into it. But that's precisely it. This discrete measurements, especially of quantitative values, are going to be sort of bins or binning, right? Like this digital scale is going to bin everything that's beyond its specificity into the bin that represents the unit of measure that it can handle, to the specification that it can handle. And then everything else will just be binned into that discrete bucket.
So one other place that we can think about continuous and discrete is time. So if we think of a radial clock, then that's giving us that continuous measure where our time is kind of anywhere on that dial. And then in the discrete side, we may be measuring time to the second or to the minute, to the hour, day of week, or so on.
Right. We could bin those units of time by, for example, all of the Novembers, for example. Yeah, totally.
Yep.
So let's dive into this. When we're taking a continuous measurement, that allows any number of values along a given range. And time is a really good example of a continuous measurement. That another one might be the temperature outside, right? That can be kind of any number of possible values, and there's no real finite distinction between one temperature and the next, or one time of day as the next. But on the other hand, we could take both of those things and discretely bin them into discrete measurements that only allow specific countable values, like, for example, the Novembers or the size of a shoe, right? So, for example, I wouldn't be able to go down to the local store and ask them for a size 10 and 7/16 shoe. They just don't
Yeah.
come like that, right?
Yep.
Now,
So,
Keith, in the graphics that you were just showing, I noticed that you had bins 1, 2, 3, and 4. But bin number 2 didn't have any values in the discrete, right? We just didn't have any measurements that fell into that category. So by default, Tableau isn't even going to show that bin. It's just going to skip from 1 to 3 and 4. Just something I wanted to notice and call out about some of the differences that we're going to experience when we're dealing with continuous and discrete, is that continuous actually highlights potential gaps in that measurement, where it's a little less obvious when you're binning it into these discrete categories.
oh my gosh, I'm so glad you brought that up. This is Jonathan's forte, and in our first season, we spent so much time talking about sparseness. And if it's a discrete dimension, you can show missing values, but it'll only show the missing values that are between the inner and outer range. Then you get into all of these other techniques with Tableau, like padding and scaffolding. It's a really good
Mm-hmm.
call out, Robert. Okay, so furthermore, continuous measurements can be decimal values and fractional values, right? Like that 10 and 7/16 measurement can very easily come out of a continuous measurement. Discrete values traditionally can only be ordinal and integer values, although in Tableau, this is one of the magic things that we'll get into in the future, talking about the application of these
Mm-hmm.
techniques. We can turn any column of data in Tableau and we make the decision whether it's discrete or continuous. So I could take a value like sales that has fractional values and just in Tableau work with it as a discrete pill on the canvas. Continuous measurements, they tend to require an in-depth method or tool in order for analysis and in order for measurement. So we tend to work with these continuous values in kind of more in-depth means like curves and skews, whereas the discrete values are something that's really easily counted on a number line, and we'll tend to use those discrete
Mm-hmm.
values for separating, say, marks on a scatter plot or columns or rows on a crosstab in order to distinguish different bars. And so these continuous values, they're very often represented as an area or a curve or as a line, whereas the discrete values, those are often represented as points or bars or table headers. You get the idea, right? One is
Mm-hmm.
continuous and the other is discrete. And then lastly, these continuous values, they can vary over time. And what's really interesting is that they can have many values at a single time, right? So if we go back to making spicy ketchup in Texas, let's just say I've got a pot on the stove, right? And I'm making some spicy Texas ketchup at home. And I get out my digital thermometer and I stick my thermometer in my pot of spicy ketchup because I only want to get it to let's say 180 degrees. As I move the thermometer around in the pot, I could get readings of 176 over here, 174 over here, 178 over here. And so it's not necessarily the case that the one pot of ketchup is exactly 170 degrees or 175 degrees
Mm-hmm.
uniformly across the entire area. There's a continuum of temperature there when I take those measurements.
Yeah, so it seems to have some recognition that the points that we measure aren't all inclusive. There may be some things in between the points that we've actually recorded. Um, and yeah, we want to have some understanding of that in between space.
The data is not the reality.
Mm-hmm.
Right? The data is by its very definition some measurement and simplification of reality. But if we were to attempt to get maximal fidelity in our data, we would just ultimately wind up back at reality, right?
Mm-hmm.
Yeah, and that's a really good segue, Robert. Whereas the discrete measurements, those are going to remain constant. And I'm just going to say that this vat of spicy ketchup is 177 degrees for the sake of that discrete measurement there. And as we've talked about in earlier sense-making episodes, the importance of tidy data and how Tableau prefers tidy data, you can go back and watch those earlier conversations. Really, as a starting point, Tableau would prefer that we take every observation and treat that observation as a new record in a data set where the things that vary are each in their own column. And the values of those variables are stored in the cell, the intersection of the observation with the variable. And so now when we're beginning to talk more about discrete and continuous, what we're getting into then are these types of variables. So if our data capture mechanism is instrumented in order to capture data and to capture these observations of variables, at the highest, broadest level, we can have variables that are categorical or we can have variables that are quantitative. And within the categorical variables, those can be nominal or ordinal. Nominal is when I just give a name to a thing, and ordinal is when it follows some kind of sequence.
Mm-hmm.
And the quantitative values, this is where we get into, can be discrete
Yeah.
or continuous.
Yeah.
And so the nominal things is just like giving a name to something: apple, horse, dog, cow, and there's no particular sequence to them.
Mm-hmm.
Whereas the ordinal categorical variables are still placing that observation into a category, but now the categories have some kind of sequence to them, like small, medium, large. There's an order to the categories. Whereas in the quantitative variables, the discrete stuff is everything that we've talked about up until now, and the continuous stuff is also everything that we've talked up until now. The discrete things are separate and distinct from one another, whereas the continuous variables are measured along an infinite number of possible real values, falling anywhere along the number line. And so to me, this is where things really get fascinating, because if you take this and you boil it down, what you wind up observing is at the end of the day, there's really only one continuous. There's really only one of these types of variables that can be continuous, and those are quantitative variables. Both quantitative and categorical variables could be discrete, but only the quantitative things could be continuous. So in other words, that size 10.5 shoe that I get when I go to buy a sneaker, it only is a category of sneaker that's available to buy. And that if I need a subsequently larger size because this one doesn't fit well, I need to move up to an 11. That size of shoe just doesn't fall at infinite numbers of possibilities along the number line.
But the infinite number of possibilities is how many of that size of shoe did you sell? Was it 15? Was it 1,500? Was it 15,000? There could be any variation anywhere in between those numbers.
And that's because that volume of sales, that quantity of sales, is a quantitative variable as opposed to the categorical variable of the size of the shoe.
Right.
And at this, and I think this, I'm trying this on, so I'm thinking about it. I haven't thought of it in this way before. And some of the places where I go, no, that continuous is a discrete. It's really that, to use Robert's shoe sales idea, there's places where I may do a derived variable. We could have any number of shoe sales, and then I'm deriving a variable to say, to bin that into bins of 100 sales at a time per unit of time. So I'm taking my continuous value, turning it into a discrete. Or maybe I'm doing a KPI kind of measure where I'm like, okay, if the sales were greater than 5,000, that's high or else low. I haven't changed my continuous variable. I've created a new variable, which is discrete based on the continuous variable.
Yeah, and that example really illustrates that those quantitative variables, they could be either discrete or continuous. But the categorical things, they just can't be continuous. They're categorical and discrete by nature, right?
Yep.
Okay, so to wind up or begin to wind up this theory conversation, we'll move in our next conversation more into discrete and continuous applied. Let's kind of get a little bit into the application of these concepts inside of Tableau. Remember, the canvas in Tableau is the specification for the view, right? And so as the author, I have agency over the visualization that Tableau renders. And the way that I exert that agency is by dragging and dropping and configuring the arrangement of pills on the canvas. And so I think it can be helpful to just consider where and when are discrete and continuous available to be used on the canvas. So for example, I could use discrete and continuous marks, pills on the marks card. I could use discrete and continuous pills on the filter shelf. And those pills are going to behave differently. The same column of data would give me a different sort of interface with the filter if I treat it as discrete or if I treat it as continuous. But I can do both on the filter shelf. And the same is true on the rows and columns. I can place discrete pills on the rows, and I can place discrete continuous pills on the rows and on the columns. And again, I'm going to get differing behavior. We'll look at that in the future. But to me, one thing that's really fascinating is that it's just not possible to place a continuous pill onto the pages shelf. And why would that be? It's very much like the size 10.5 shoe. I can't be half turned of a page. I can't be partially between one page and the other. So it makes sense then that I can only have a discrete pill on the pages shelf because I neither need to be on this discrete page or the next discrete page, and there's not a continuum of infinite possible values in between the pages that I might possibly want to animate my visualization on.
Right.
Okay, so back to where we began, ketchup and mustard. It really turns out to be much more complex than you might at first imagine, right? Like, is ketchup discrete, continuous, right? So these are the types of things as sense makers that as we get to acknowledging Robert's observation that the data is a map of the territory, but it's not the territory itself, the instrumentation and the measurement and our treatment of the observations and variables and values that come back from that instrumentation in the data sets that we're working with are really going to make a big difference in the type and quality of sense that we can make from that data.
Exactly.
Yeah.
Okay, so to wrap it up, I've got a lovely Zen cone here. This one to me is just beautiful. The universe around us is ever transient. There's only one continuous, right? There's one consciousness, one love, one continuum of reality. Everything else is ego, labels, and discrete binning.
I'll go with that.
Okay. A little bit metaphysical, but it translates to data. I can see that.
A little metaphysical, yep. Yep. You can look at it through the lens of the kind of philosophy of your choosing. Okay, well, thanks, guys. That was fun.
Yep. All right.
We'll see you next time.
Thanks.
All right. Thanks, Keith.
Okay, bye-bye.
Bye.
Action Analytics.